Hi, grade 6. Hope you had a good weekend. I'm back with another math video. With me, of course, as always, is my sidekick, Berkeley. And Berkeley is not nearly as sleepy today. She is instead protecting the home from squirrels that like to jump on the bird feeder that you can see outside my window there. So, as I'm teaching you guys about surface area, Berkeley the Wonder Dog will be protecting us from squirrels. Okay. All right, so today we're going to learn about surface area. So if we go to our original notebook video, we looked at area, perimeter, volume, and now we're at surface area. So the definition for surface area is the total area of the surface of a three-dimensional object. And another way to think of it is this. We're going to add up the area of all the faces, okay? It is measured in centimeters squared because we're studying area. We're studying a whole bunch of areas, the areas of all the faces of a 3D object. So, if I went back to my volume video, okay? And if we put out of our head for a minute, volume. So let's just move this somewhere else. We'll put it over here. Oop, there we go. Okay. So if we instead thought of this in terms of surface area. So this cube is surface area. That means we're going to add up the dimensions of all the faces of this cube. So think of it like this. There are 6 faces to this cube, and we know that the area of each face is 3 times 3. So every face, the area is 3 times 3. And if we added those up, 3 times 3, 6 times, well, we know that 3 times 3 is 9. 9 times 6, because there's 6 faces, would be 54. So the surface area of this cube would be 54, because we would quite literally go 3 times 3, 3 times 3, 3 times 3, all the way around. So all the faces, we would add up the total area, right? Now, another way of showing that, so I've made some modifications to our volume work. So if we can forget about volume for a second, this is the old volume video that I showed you. I've taken these objects and I've recalculated them for surface area. So the answer is still volume here because it's centimeters cubed. But on the next page, I'm going to show you how this fish tank, let's say, instead of calculating the volume, we would calculate the surface area. So there's a couple of ways to calculate surface area. All right. So the same object that I just had, okay, on the previous page. Remember, this is one of the first, this was the first rectangular prism that we studied for volume. But now if we think of it in terms of surface area, what I've done is I have taken every face on this object and copied it here, okay? So we have this face, which we know has a base of 6 and a height of 4. So that's this face here. So the first face, base of 6, height of 4, is calculated here. But we know that there's 2 of them, right? There's this face, and then there's the parallel one. Okay, so think of the front face, the back face. 6 times 4, 6 times 4. And we also have these 2 faces. 3 times 4, 3 times 4. So we've now covered 4 of the 6 faces, okay? So we have this face, and we have this face, and now we have this face and this face. 3 times 4, 3 times 4. Now the last face we have to do is the top and the bottom. Okay, so if you think of it as front, back, side, side, we can think of this as top and bottom. So the area of these 2 faces is, the bottom one would be 6 times 3, base times height, base times height. So we've taken every single face from this 3D object, and I've put all the faces into their own individual measurements. Now, you could also do this with a net. You could actually attach the faces. That might help you. But this is just a way of showing you how, if we have a 3D object, it can be broken down into the individual faces, okay? So what I'm going to do here quickly, with the help of my calculator, is I'm going to add all these up now. So the answer for each of these, okay? So we're going to have 6 times 3, right here, is 18. Now we know when something has 2 faces, we might as well times it by 2. So if the answer to this face is 6 times 3, which is 18, then the answer to this face is going to be 6 times 3, which is 18. So it's going to be 36. I'm actually going to make it a little smaller here. Okay. So 36. Now, for this face, okay, so think of it as the front face, 6 times 4, 4 is the height. We know that 6 times 4 is 24. But we also know that there's 2 faces. There's the front and the back. So 24 times 2, or 24 plus 24 is 48. So now we've done the area of these 2 faces and these 2 faces. So now the small ones, the side ones. So we know that 4 times 3, or sorry, I should say 3 times 4, base times height, 3 times 4, our answer is 12 and 12. So 12 plus 12, or 12 times 2, gives us 24. So again, the area of these 2 faces is 36. The area of these 2 faces is 48. And the area of these 2 faces is 24. Okay? And if we were to use our calculator like I'm doing right now, just to be sure, okay, and we go to our calculator and add up 36 plus 48 plus 24, we would get 108 centimeters squared. And the reason it's squared is because all of these are area measurements, okay, using 2 measurements. So it's not the number of faces, it's 2 measurements. So we're adding up the area of all these faces to get our surface area answer, okay? So if it helps, you can put SA equals surface area equals 36 plus 48 plus 24 for a grand total, a grand surface area of 108 centimeters squared, okay? Now, another way to do this. So remember this shape, okay? We calculated the volume, okay, length times width times height, and we got 48 centimeters cubed. Now forget about the volume for a second. We're now going to calculate the surface area of this. So for this object, I didn't lay out the faces, all right? If you guys wanted to lay out the faces, if you wanted to draw a bunch of different rectangles, okay, to help you with base times height of each face, you could. Or you could just do the math. So once you realize, okay, Mr. Griffin, I know there's 6 faces, I'm going to go one at a time. So I know that this face is 3 times 8. Okay, 3 times 8. And I know that because it is a 3D shape, it has its opposite. So if this is 3 times 8 here, then this is 3 times 8 here. 3 times 8 equals 24. All right, Mr. Griffin, I'm on a roll. So I know that 2 times 8 is this face, which means its opposite is 2 times 8 is here. So I've done 1 face, 2 face, 3 face, 4 faces. I got my answer, and I'm almost done surface area. So the last face, this one here, and this one here. Well, the base is 3, the height is 2. Okay, the base is 3, the height is 2. Mr. Griffin, I've calculated all my faces. So the surface area is 24 plus 24 plus 16 plus 16 plus 6 plus 6. Or you could do it a lot faster. You don't have to add up all the faces because we know that they have an opposite end. So here, instead of doing 6 equations, I've cut it in half to 3. And again, use your calculator. Because we know that 3 times 8, we could do it twice to show the 2 different faces, 1 face, 2 face, but we know that there's going to be another face. So instead, why not go 3 times 8 times 2? We'll get the same answer. 24 plus 24 is 48. Okay? So again, we have another face, 2 times 8. Instead of doing it twice, we just say 2 times 8 times 2. 2 times 8, we know it's going to have an opposite, times 2. Okay? And you guys get the idea. So for the last face, the top and the bottom, 3 times 2, instead of going 3 times 2, 3 times 2, 3 times 2 times 2. Okay? So there is the area for all 6 faces. I just added a step. All right? I just added multiplying by 2 to cut this in half. We still have to add them up. 48 plus 32 plus 12 for a grand total 92 centimeters squared. So that's a way to make it a lot quicker. Instead of drawing the faces, once you understand your dimensions, if you showed me these 3 calculations, that would be just as correct as showing me all the faces. Okay, so as we get into junior intermediate grades, we can simplify. And simplifying for me means you guys know the dimensions of the faces. You can just show me the math. Okay, so it might be a little simpler for you. Okay, so the last one I kind of looked at is we didn't have a volume answer for this one, right? For the last one. I kind of let you guys do it. So I replaced it. Instead of a volume question, I made it a surface area question. And I wanted to show you guys something. So with this rectangular prism, it can still have 2 faces that are squares. Okay? So here we have 2 times 2. Now, again, what we can do to simplify this is 2 times 2 times 2. Okay? We know 2 times 2 is 4. We know this is going to be the same, so I just did 2 times 2 times 2. But for this one now, we know that the height of every single other face is going to be 2. That's the only other dimension we're given. So instead of going 12 times 2, 12 times 2, 12 times 2, 12 times 2, I just did 12 times 2 times 4. front, you can think of it like that, back, top, bottom. They're all going to have a height of 2. So if you go 12 times 2 times 4, it's a quicker way of adding 4 faces. Okay? And we add them up. 12 times 2 times 4 is 48. 2 times 2 times 2 is 8, for a grand total of 56 centimeters squared. Okay, so whatever way you do it, taking the faces, okay, isolating them, so it's simpler for you to visualize it perhaps, or calculating the area of all the faces. You can do it this way if you like. If it helps you break it down, you go, okay, Mr. Griffin, I got one face done, 3 times 8, 3 times 8, I got another face done, do it that way, okay, if it helps you simplify it. I think this is your best bet. You don't have to draw all the faces. You know that every face is going to have its opposite. In some cases, it might have 4 faces, like if it has square ends. But this might be your best bet, all right? Right here is doing the area of each face. So surface area, once again, is calculating the area of each face of a rectangular prism. And I say rectangular prism because it will change when we get to triangular prism. You could probably guess how. Excuse me. So a couple of examples of surface area and why we need to know it, okay? And the one I always think of is presents. Gift wrap, okay? The precise gift wrap that goes around an object, that's surface area, okay? Covering the entire outside of a 3D shape, right? And the other one that comes to mind is when you make materials. So one material people might make is a dog crate. So you spend all this material to make a 3D object. This is the material outside the object, and lo and behold, something might even cut a hole in that object because they're a puppy and they're a bad puppy. And they want to see what's going on in the outside world and sniff. So they chew a hole through that crate. Who could that person be? Well, let's see if there's any suspects. Oh, there's a suspect right there. Not the best crime committed if you're going to show your face through the hole. Right? So the best thing to do, obviously, is when you're creating this object, make for a zipper hole in the top. And perhaps when you go out to run errands and you have a puppy, you make sure that this is open so that the puppy can see into the world and not chew a hole through the crate. So that's surface area. I know it may seem like a lot, but basically what it really is its area, okay? It's the area of a rectangular prism. It's just for a bunch of different faces. So once you calculate how many faces there are, all you have to do is area for each face, okay? That's the best way to think of it. I'm going to repeat that. Once you figure out that it's area, you're just calculating the area of each face. Okay, so you can basically break it down to these 3 equations because you know that each face is going to have its match, okay, on the opposite end. So that's surface area. If you wanted to practice a few of your own, there are multiple sites that have surface area questions. If you went to Math Drills, for example, and typed in surface area, a bunch of surface area questions would come up. You can try them yourself. You could draw a 3D shape and put your own dimensions and test it that way. But it's really just a concept of adding up the area of all the faces of a 3D object. So the last one that I will call up a 3D object is this here. So this is, if you can see it, I tried to move some stuff out of the way. So this is Berkeley's dog food container. Okay. Yeah. So with Berkeley's dog food container, oh, some pictures came up there. With Berkeley's dog food container, if I, let's see if I can get it in. Oh, you know what might be a good idea? I can do this. There. That's better. Okay, so with Berkeley's dog food container, surface area, okay, the distance around a 3D object, I can open it up. Oh my goodness. I've opened it up, and who's going to come? There you go. Oh. So there's Berkeley the Wonder Dog teaching about surface area. Okay, sorry about a bit of chaos there at the end, but you guys get the idea. There are Prodigy questions for it. The EQAO challenge, I will answer that on Wednesday. We'll pick a winner on Wednesday. All right? Okay, guys, Mr. Griffin out. Just going to save it here.